Good morning. Binomial distribution exercise 8.1, sum number 6. A bag consists of 10 balls, each marked with one of the digits 0 to 9. If 4 balls are drawn successively with replacement from the bag, what is the probability that none is marked with the digit 0? Okay, write the solution. Let capital X equal to number of balls. Let capital X equal to number of balls marked with digit 0. Marked with digit 0. Therefore, P equal to small p. Therefore, P equal to probability of drawing a ball, small p equal to probability of drawing a ball from 10 balls, marked with digit 0, marked with digit 0 equal to 1 upon 10, 1 upon 10, right down. So Q equal to 1 minus P, so 9 upon 10. Okay. Now what is PMF of X? P of X equal to NCX P raised to X Q raised to X. So here it is nothing but, before that we should have written this follows binomial distribution, etc. Okay. So what is N? N is nothing but 4. 4 balls are drawn, right? Just a minute. Also N equal to 4. Okay. So this is 4cx 1 upon 10 raised to x 9 upon 10 raised to 4 minus x. Okay. Where x assumes values from 0 to 4. Okay. Now what is asked? Required probability P of x equal to 0. That is probability that none of the balls is marked with digit 0. So this is 4c0 1 upon 10 raised to 0 9 upon 10 raised to 4. Now 4c0 is 1. So what is the required answer? 9 upon 10 raised to 4.
Sum number 7. On a multiple choice examination with 3 possible answers for each of the 5 questions, what is the probability that a candidate would get 4 or more correct answers just by guessing?
Before we start writing solution of 7, initially I had written q raised to x. Please make this correction. P of x is ncx p raised to x q raised to not x but n minus x. Now this is correct. Okay, right now. Solution for sum number 7. Let capital X equal to number of correct answers. Let capital X equal to number of correct answers. Next line, P equal to small p. P equal to probability of getting correct answer. Small p equal to probability of getting correct answer equal to 1 upon 3. Therefore, see on the screen, Q equal to 1 minus P, that is 2 upon 3. Also, what is small n? Number of questions 5. So n equal to 5. Therefore, capital X follows binomial distribution with parameters n comma p, but n is 5 and p is 1 upon 3. You have to write this in the last solution. We should have written this. You can make that addition. So capital X follows random, other capital X is a random variable which follows binomial distribution with these parameters. Okay. After that, PMF, probability mass function. PMF of X is P of X equal to NCX, can be remembered easily. I have explained the logic also. P raised to X into Q raised to N minus X. So here you have to substitute particular values. N equal to 5. So P of X equal to 5CX. 1 upon 3 raised to X. 2 upon 3 raised to 5 minus X. Now, X can assume value 0, 1, 2, 3, 4, 5. Okay, just a minute. Let me check. Yes, correct. Therefore, what is the required probability? P of 4 or more correct answers, that is P of X equal to 4 plus P of X equal to 5. So 5C4, which is 5, 1 upon 3 raised to 4 into 2 upon 3 plus 5C5, which is 1, 1 upon 3 raised to 5 into, I haven't written that, 2 upon 3 raised to 0, which is 1. Okay. Now it can be taken common. 1 upon 3 raised to 4. So what remains in bracket is 5 into 2 by 3, that is 10 by 3 plus 1 by 3. Simplify to get 11 upon 243. Sum number 8. A person buys a lottery ticket in 50 lotteries, in each of which his chance of winning a prize is 1 by 100. Find the probability that he will win a prize at least once. Second part, exactly once. Third part, at least twice. Solution. Let X be the number of winning prizes. What is P? Probability of winning a prize. It is given to be 1 upon 100. So what is probability of failure? Q. It is 1 minus 1 by 100. That is 99 by 100. Now what is number of Bernoulli's trial? It is 50. So n equal to 50. Therefore, X follows binomial distribution with parameters 50 and 1 upon 100. What is probability mass function of X? P of X equal to X is NCX P raised to X into Q raised to N minus X. Substitute the values. So it is 50CX Okay. 1 upon 100 raised to x, 99 upon 100 raised to 50 minus x, x goes from 0 to 50. It is better if you mention this. First part, what is required probability? Probability that person wins a prize at least once. At least once means one or more than one time. So P of x greater than or equal to 0. Here it is better to consider probability of the complement. What is probability of complement of at least once? None. So subtract probability of complement from 1, you get probability of required value. So it is 1 minus P of x less than 1, that is 1 minus P of 0. Now P of 0 is 50C0, which is 1. Don't waste time in finding this using 50 factorial upon. Directly write 1. 1 upon 100 raised to 0, 1. 99 upon 100 raised to 50. So this is the required answer. 1 minus 50th power of 99 by 100. Second, probability that a person wins exactly one prize. Simple. P of x equal to 1. 50C1 is 50. 1 upon 100 into 99 upon 100 raised to 49. Rearrange the terms. So 1 upon 2 into 99 upon 100 raised to 49. Is it? How come? Okay. See, they have 50. They have multiplied numerator and denominator by 2. So 100 upon 2. So this 100 gets cancelled. Good. So this is the final answer. Now, third part. Probability that a person wins the prize at least twice. At least twice means P of x greater than or equal to 2. So we consider the complement. What is complement of P of x greater than or equal to 2? X less than 2. Actually, not complement of probability, complement of an event. So we should say x less than 2. This is the complement of x greater than or equal to 2. So it is 1 minus P of x less than 2. That is 1 minus in bracket P of x equal to 0 plus P of x equal to 1. Substitute. You have to simplify patiently. See what can be taken common. In this case also it is written as half into. So 1 minus 99 upon 100 raised to 49 can be taken common to get this in bracket. Simplify. So final answer is what? 1 minus 149 into what? 99 raised to 49 upon 100 raised to 50. Sum number 9. In a box of floppy disks, it is known that 95% will work. A sample of 3 of the disks is selected at random. Find the probability that first none, second 1, third 2, and fourth all 3 of samples will work. Okay, read up. Solution. Let capital X equal to number of working disks. Let capital X equal to number of working disks. P equal to small p. P equal to probability that disk works. P equal to probability that disk works. Therefore, P equal to 95%. Percent means per 100 for every 100. So 95 upon 100. Simplify. So 19 upon 20. So what is Q? 1 minus P, that is 1 upon 20. Number of floppy disks 3. So n equal to 3. Therefore, x is a random variable following binomial distribution. Which parameters? N small n, which is 3. And what is P? 19 by 20. Right up. Then what is PMF? NCX P raised to X Q raised to N minus X. So in this case, P of X equal to N is 3CX 19 upon 20 raised to X 1 upon 20 raised to 3 minus X. Now X can assume which values? 0, 1, 2, 3. Now the first part, probability that none of the floppy disks works, that is P of X equal to 0. So 3C0, which is 1, 19 upon 20 raised to 0 is 1. So it is 1 upon 20 raised to 3, that is 1 upon 20 cube. Second part, probability that exactly 1 works. So P of X equal to 1, that is 3C1, 19 by 20 raised to 1, 1 upon 20 square. 3C1 is 3, 19 3s are 57, so 57 upon cube of 20. Third part, exactly 2 work, exactly 2 disks work. So P of X equal to 2. So 3C2, which is 3, 19 upon 20 square into 1 by 20. That is why I have written 3 into 19 square upon 20 cube. See, if time permits, it is better to find the final answer using log tables instead of writing in this fashion. Fourth part, probability that all the 3 floppy disks will work. So P of X equal to 3. So 3C3, which is 1 into 19 upon 20 raised to 3. I should have written into 1 upon 20 raised to 0, but that is 1. So final answer is cube of 19 upon 20. Okay. Now, sum number 10. Find the probability of throwing at the most 2 sixes in 6 throws of a single die. So what is X here? Number of sixes. What is P? Probability that die shows 6 in a single throw. So it is 1 upon 6. So what is Q? 5 by 6. Now number of throws is N equal to 6. So X follows binomial distribution with which parameters? 6 and 1 by 6. Now what is probability mass function? P of X equal to NCX P raised to X into Q raised to N minus X. That is 6CX 1 upon 6 raised to X 5 upon 6 raised to 6 minus X. X assumes values 0, 1, 2, 3 up to 6. Now, what is asked? Required probability that at the most 2 sixes. At the most 2 means what? X less than or equal to 2. That is required probability P of 0 plus P of 1 plus P of 2. Find out. So substitute the values in this required probability P of 0 plus P of 1 plus P of 2. 6C0 is 1. So this is just 5 upon 6 raised to 6. 6C1 is 6 and 6C2 is 15. I have taken 5 upon 6 raised to 4 common. That's why I get 25 by 36 plus 5 by 6 plus 15 by 36. What is LCM? 36. So 25 plus 30 plus 15. So 5 upon 6 raised to 4 into 70 upon 36. You can write this answer as final answer, but in MCQ, they may give this as correct option. 70 upon 36 is basically 35 upon 18. Now it contains 5 by 6. That is why I have written 70 upon 36 as what? 7 upon 3 into 5 by 6. So 7 upon 3 into finally 5th power of 5 upon 6. Sum number 11. It is known that 10% of certain articles manufactured are defective. What is the probability? that in a random sample of 12 such articles, 9 are defective. Actually, I have written important steps. You can complete the solution afterwards. X is number of defective articles. P is 10% are defective, means 1 by 10. 10 by 100 means 1 by 10. Q is 9 by 10. Number of Bernoulli trial is 12. So random variable follows binomial distribution with which parameters? 1 upon 10, 12. So required probability exactly 9. So P of X equal to 9. 12C9, 1 upon 10 raised to 9 into 9 upon 10 raised to 3. You have to simplify to this. So what is the final answer? The probability of getting 9 defective articles is 22 into what? 9 cube upon 10 raised to 11. Sum number 12. We are given that X is a random variable which follows binomial distribution with parameters NP. First part, n equal to 10, p equal to 0.4. Find E of X and variance X. Now, what is E of X? NP. Substitute the values to get 4. What is variance? It is NPQ. Now P is 0.4, so Q is 0.6. Substitute the values. Don't read this as 0.1611. This is page number as far as this slate is concerned. So it is 0.6, not 0.16. So 2.4. Second part, here we are given P as 0.6. We are given E of X, okay? Find N and variance. Now write formula for E of X. Out of 3, 2 are known. So find third. So N equal to 10. What is Q? 1 minus P, that is 0.4. What is variance? NPQ. So 2.4. Now in the third part, N is given to be 25, expected values 10. But E of X is NP. Substitute to get P equal to 2 by 5. So what is Q? 3 by 5. So what is variance? NPQ 6. What is asked? Standard deviation, positive square root of variance. Root 6. You may write root 6 as the final answer or approximate value 2.45. Fourth one, N is given to be 10. E of X is given to be 8. But E of X is NP. So that gives me P as 4 by 5. So what is Q? 1 by 5. What is Vx? NPQ. So 8 upon 5. So that's it for today.